Our first lesson in chapter 7 is about dilations. So a dilation is a type of transformation. Transformations we've worked with in the past are things like rotations, reflections, translations. So we're just adding on to that list. The reason that we didn't talk about dilations earlier in the year, though, when we did all of those other transformations, is that all of the other transformations we've learned about are what we call rigid transformations. So after we move the figure, it ends up being the same size. With a dilation, not only do we move the figure, but it will be a different size. So it's either going to get bigger or smaller. The transformation enlarges or reduces a figure proportionally with respect to a center point and a scale factor. The scale factor is usually given by a lowercase r. So in this case, r, our scale factor is 2. That means that this figure is going to get twice as big. If the scale factor were 3, it'd get 3 times as big. If the scale factor were 1.5, it would get 1.5 times bigger. Scale factors can also shrink an object. So if I had a scale factor of less than 1, let's say my scale factor were 0.5, then my new image would only be half as large. So not only does our shape grow, so in this case it's going to get twice as big, it will also move away from a center point. So we're going to take this green trapezoid, we're going to make it twice as big, and we're going to move it twice as far away from this dot over here. In order to do that, we're going to get some measurements. You can measure in centimeters or inches, doesn't really matter. I tend to use centimeters because then if it's not a nice number, I'm not dealing with like 1/16 of an inch. So we're going to say the distance from our center of rotation to this point on my original figure is 2.1 centimeters. Sometimes I like to draw a line in there between my two figures. You don't necessarily have to, but you'll probably see me do that. And then from the center point, we're going to keep our ruler exactly where it is, and we are going to multiply that distance by 2. So 2.1 centimeters times 2 would be 4.2 centimeters. Then from our center point, we'll measure out 4.2 centimeters. So 4.2 would be right about there. Again, you could draw a line connecting those. It doesn't really matter. But that's going to be a new point on our figure. Then we're going to have to do that for all of the other points. So let's say I want to measure to this vertex now. I'd take my ruler, get that distance. I'm going to say that looks like a 3.2. Again, sometimes I'll draw a line in there. You don't necessarily have to. We're going to take that distance, multiply by our scale factor. 3.2 times 2 would be 6.4 centimeters. So then along that line, I'll measure out 6.4 centimeters. That would be about there. I'm going to keep going. Let's do this corner point here. So measure that distance. If you want to draw a line, go for it. We're going to say that one is 5.5 centimeters. 5.5 times our scale factor of 2 would be 11 centimeters. So measure out to 11. I've got a vertex there. And then I've got one more corner. This one looks like it's 6.3 centimeters away from my center of rotation. 6.3 times 2 would be 12.6. So 12.6 would be about there. And then I'm going to move my ruler out of the way, and I'm going to connect all these points. And you can use your ruler to connect the points so you have some nice straight lines. So that's my new trapezoid. It got twice as big and twice as far away from my center of rotation. Just like any other transformation, we would call the original thing our pre-image or our original, and then we'd call the second thing our image. So something after a translation or a transformation is an image. And if we had points on this, let's say this point were A, its corresponding point on the image would be A prime. If this had been B, this would be B prime. So that's how we do a dilation. Now we've got, I think, a word problem with the dilation already given to us. So we want to determine whether the dilation from figure K to K prime is an enlargement or reduction. That means exactly what you think it means. Enlargement gets bigger, reduction gets smaller. Then find the scale factor of the dilation and x. So if we're going from K to K prime, K is bigger than K prime, so since it gets smaller, that's a reduction. Next thing we need to find is the scale factor. So you'll notice in my first example, if I were to measure the distance between a point on my original and a point on my image, I would multiply by the scale factor to get from the point on the original to the point on the image. So like our distance from the center to A was 2.1. The distance from our center to A prime is 4.2. I multiplied by the scale factor. We can take that multiplying and rearrange it. Our scale factor, R, is always going to be the distance to the image divided by the distance to the pre-image. So in this case, to go out to our image, our new thing, that would be K prime, would be 3 units. The distance to go out to our pre-image, so just plain K, was 9 units. 3 divided by 9 is 1/3. So our scale factor is 1/3. Our image is 1/3 as big as the pre-image. And then the other thing we have to find is x. That's just some basic algebra. If the entire length of this segment is 9 and the small segment of it is 3, x is going to be 6. So again, your formula for R, your scale factor, is always going to be your image divided by your pre-image. And you can double check your work when you're done. I got 1/3 and it was a reduction, so that makes sense that it's less than 1. If I had happened to do this problem and I got 3 or 3/1, I would know that I made a mistake and had my image and pre-image flip-flopped, because a reduction should have a scale factor less than 1 and an enlargement should have a scale factor more than 1. All right, last problem we're going to do is a dilation on a coordinate plane. So we don't have to use a ruler for this one. We'll just use the boxes that are already on the grid. To describe a dilation centered at the origin in the coordinate plane, we're going to take the point xy and move it to r times x, comma, r times y, where r is the scale factor. So we're going to start with our original points. So it looks like here A is at -1, 3. B is at 3, -1. And C is at -1, -1. And our scale factor is 1.5. So essentially, we're just going to take every number and we're going to multiply it by 1.5. So -1 times 1.5 would be -1.5. 3 times 1.5 would be 4.5. B prime, 3 times 1.5 would be 4.5. And -1 times 1.5 is -1.5. And then for C prime, we've got two -1.5s. All right, and then I'll do my best to plot those fractions. So A prime, I'd go back 1.5 and up 4.5. It'd be about there. For B prime, I'd go over 4.5 and down 1.5. And then for C prime, I'd go back and down 1.5. So that is my new figure. It got 1.5 times larger, and each individual point, like if you look at A compared to A prime, moved 1.5 times away from the origin.